Yeah, so for today, I was gonna introduce the securiCAD project or the concept and how it works. And then I'm gonna talk a bit about securiCAD Vanguard, that is securiCAD for AWS. And I'm gonna have a brief demo of that. And then I'm gonna talk about automation and integration with securiCAD Vanguard and its SDK, and also do a demo of that. So let's jump into it. So the high level concept is fairly simple. We generate a model or build a model of your IT architecture. You can do this automatically, like in securiCAD Vanguard, or you can do it manually, which I think UR will show us later. We then simulate attacks on these models, and based on that, we can then find, prioritize, and mitigate weaknesses in our model and in our IT architecture. So as I mentioned, these models can be built automatically or manually. And also you can combine the two, so you can have some parts of the model manually created and then enrich the model with data, for example, from a vulnerability scanner. And typically you can generate the model from anything that describes any part of your environment. For Vanguard and AWS, it's very easy to get a hold of the data because it's available from the AWS APIs. So we can actually use that to generate a model, basically a one-to-one mapping from our AWS environment to our model. And there's also the SDK for automatic modeling of your proprietary or custom data sources. And then we simulate attacks on these models. And all of the logic for the simulation is actually built into the model. So you don't have to have any security expertise or know per se how the domain works from an attacker's point of view. So all of that is built into the model. So based on the model of our IT architecture, we then basically generate huge threat models of every conceivable attack and attack combination that is possible in this model. So that is the attack steps between and inside assets in our model, just like the picture here. So if you do spear phishing and you're able to get a hold of a set of keys, you can then use that to elevate your privileges, for example, and then compromise a database, for example. And all of that logic is actually built into the model. And most of the logic is actually just the logic of the domain. So how does assets work with each other? So if you have an EC2 instance in AWS, a virtual machine, how does that work with subnets and other EC2 instances? All of that is just the logic of the domain, and it's not about specific or exotic attacks. But a few of the things are actual attacks, like spear phishing or exploiting a vulnerability or finding a new vulnerability. And for that, we can actually have probabilities. So what is the likelihood of an attacker being able to, for example, spear phish a user? So and all of that is also built into the model. So you don't have to know any probabilities yourself. And we use Bayesian methods like Matthias describes earlier. We use Monte Carlo simulations to actually simulate attacks and also do shortest path calculations in the simulation. So with that, we can find the shortest path from the attacker and its entry point to your high value assets in the model. And by using Monte Carlo simulations, we can also quantify the probability and the time it will take an attacker to actually reach your high value assets in the model. And then based on the simulation, we can then generate reports. We can get, for example, the risk exposure, the probability that the attacker will reach our assets. We can find weaknesses and also the critical attack paths. So what are the shortest path from the attacker's entry point to your high value assets? And these critical paths will also then expose the weaknesses that attacker has exploited on its way through your environment. And if there are any misconfigurations, like you gave someone too much permissions in IAM, for example, we can also find choke points. So where does the attack converge? Is there any point in our architecture that is especially weak, or a point that the attacker always exploits to reach your other high value assets? And like Matthias also mentioned, we can actually put vulnerabilities that we get from vulnerability scanners, for example, into our model and have a context for the vulnerabilities and see if they are actually exploitable at all for the attacker. So we can use that to prioritize which vulnerabilities to patch first, for example. And from this, we can also get potential mitigations. So what should we fix first and why? What are our weak spots that we should focus on? And also, of course, these mitigations can be applied in the model. You can run new simulations and try again and see if they are actually effective. Or you can fix it directly in AWS, in the AWS case, and run a new simulation and see how that affects your risk exposure. And we have an application for this, which is called securiCAD Vanguard. And this is a SaaS that is available in AWS Marketplace. And securiCAD Vanguard will automatically simulate attacks on virtual models of your AWS environment. Then, so you can find and prioritize weaknesses in your AWS configuration. And the methodology behind it is the same as for all our products. So we generate a model, we then simulate attacks on that model, and we can then find weaknesses. So the tool, securiCAD Vanguard, will never interact with your AWS environment. It will only fetch data and then do all the analysis on the actual model. So we will never interrupt any production systems or anything like that. Yeah, so I'm going to show a brief demo of how this works. On our YouTube channel, there is a more comprehensive demo that we did on the previous webinars. You can look at that if you want a more deep dive into the tool and the background behind it. So let's jump into Vanguard. And as I mentioned, it's a SaaS service that we host in AWS. You can just sign up and start using it directly. So let's log in here. So the first thing we have to do is generate our model. And there are a few ways that we can give Vanguard the data to actually do this model generation. One option is to give the tool access keys for an IAM user in your AWS account. Another option, if you don't want to give access keys to the tool, you can run a Python script locally that we supply, and you can then generate and fetch data from AWS yourself locally, and then upload the resulting file to Vanguard. And the third option is to use our Python SDK, which is available on GitHub, and I will talk more about that in a minute. So for this demo, I'm going to upload some data that I have generated. So let's put in our AWS data. So this is data generated from the Python script that we supply here. And it's basically, we use Boto 3. It's an AWS Python SDK to just describe our environment. So what are all the instances, what buckets do we have, and so on, all the IAM and networking, and basically describes our whole environment. And we can also add additional files. So we can also upload, for example, vulnerability scanner data from our AWS environment to put vulnerabilities, if we have any, into context of our actual environment. So I have some scan data there. Before we move on, we can just look at the infrastructure that we are simulating. And this is a demo environment running in AWS. So we have 2 VPCs, we have an internet-facing web server, there is some load balancing, an application server, and a database. We also have a Bastion host in another VPC, and there is some peering going to the customer VPC, and we have some customer data in an S3 bucket. So this is just a picture of our environment that we are simulating on. And this is the actual environment that is running in AWS. So we are getting data from that environment. Yeah, so let's go to the next step. So the next step is to configure our simulation. And this will basically set the high value assets in our model, which will be the targets of the simulated attacker. So we can pick the assets in our environment that are most important to us. I will pick a few here, and we hit next. And the last thing we have to do is to choose an attacker profile. So this will decide how capable the attacker is in our simulation and what type of attacks the attacker have access to. So going from a state-sponsored attacker that has almost unlimited resources and access to 0 days, for example, down to the opportunist, which can only exploit known vulnerabilities and can't do any spear phishing or any fancy stuff, just drive-by hacking, basically. Let's pick the middle guy here and hit next, and then we can start our simulation. So, as I mentioned, the simulation is running on the model, so it will never affect your actual AWS environment. And the simulation is done, and we get a report here. We can just briefly look at the model. So this is our environment. We have the web server and the application and database here, the Bastion host, like I showed you earlier. And if you remember, I also uploaded some vulnerability scan data, and we can actually take a look at that here. So this is our web server. So this is the EC2 instance, or the virtual machine that is running our web server. And as we can see, there are a lot of other applications running here, and they have a few vulnerabilities, a lot of CVEs here. And we will see how that affects our risk and which of them the attacker can actually exploit in our simulation. So there are basically 100 vulnerabilities, I think, in this model. And there are a few other views of your model. So the IAM groups, for example, and the policies and stuff like that. Let's get back to the report. First of all, you get a high-level report on your risk exposure. So this means that our attacker is succeeding almost instantly and with basically no effort at all. And for each high-value asset that we picked here, we can get a more detailed report. So, for example, for this database, we can look at the time to compromise here, which is how we quantify and the metric that we use based on the Monte Carlo simulations. So this is the probability over time that the attacker will actually succeed. So this is the metric that we use to calculate the risk. And for our assets, we can also look at the critical paths. So this is the most likely path of our attacker from its entry point here on the internet to our high value asset, which is the web server that we are looking at in this case. And we can follow each step of the attacker, how the attacker succeeds and why. So the attacker is able to connect to our application here through a load balancer. And these are the security groups that are allowing that traffic to actually pass through here. attacker is able to connect to an Apache struts here and then abuse a vulnerability, a CVE here that the vulnerability scanner found. And by using that vulnerability, so the impact of it is that attacker gains code execution and is able to gain high privilege access to our web server in this case. And we can see what kind of effects that have on our customer data here in the S3 bucket. So the attacker is actually able to gain high privilege access to the web server, and connected to that web server is an IAM role, which the attacker then can use to actually gain access and read this customer data. But this is not the only successful path. It's the most likely one in our simulation, but we can crank up the detail level here and get other possible paths that are less likely and requires a lot more effort for the attacker, but they are still possible. For example, by stealing access keys here to gain access to IAM users. Based on the critical paths to all of our high-value assets on the right here, we then generate choke points. Like I mentioned earlier, these are the weak spots or where the attacks converge in the simulation. So one example here is that we see a security group here that is allowing all of this traffic to go through. We can click on that and actually go directly to our AWS console and look at that security group and see, look at the inbound rule, for example, and if anything is misconfigured, or in this case, it's actually a web server. So the traffic is supposed to be allowed from the internet, but the only thing that is protecting us from the outside world is this single or these two rules in our security group. And based on that, we get a threat summary. So what are the major threats in our environment? So in this case, there is a single CVE here at the top. There's a vulnerability that is actually exploitable due to this security group. So this is something we probably should look at. We can also look at some IAM users that are vulnerable for credential theft or privilege escalation attacks, because in this case, basically all of the IAM users are administrators. So all of them have this IAM policy. So they are susceptible to spear phishing, for example. Yeah, so that is a brief look at securiCAD Vanguard and how that works. And we are now going to look at how to actually automate this. So maybe we don't want to sit and click every day or every time we push new things to AWS, but we want to automate this process. So as I mentioned, Vanguard can be used with Python SDK that is available on GitHub. And with that, you can then run automated and continuous simulations on your AWS environment, and then integrate Vanguard into your, for example, deployment pipeline. So as a customer example that we have is that every time they push something to stage, they run a simulation, and they can see if the probability or the time to compromise has changed a lot since the last simulation, and if they made any mistakes in their AWS configuration, for example. And all of the data from the simulation is available in the SDK. So you can, for example, use it in Grafana to track the results over time and to notice any deviations in probability or in risk exposure. And since we are dealing with graphs, so the models are graphs, the critical paths are graphs, they are super easy to import into Neo4j, for example. And you can do advanced queries on your model and do investigation in that way as well. So now I'm going to show you how to run a simulation with the SDK. We're going to see how we can set high value assets automatically and continuously, because the IDs, for example, of an EC2 instance will change over time. So we will look at how we can fix that, and also how we can track the results and examine them if we see any deviations in the risk exposure, for example. Yeah, so the SDK is written in Python. It's available on GitHub, and it's also available on pip, so you can just install it easily, and then just import Vanguard into your Python project. So what you need to do to actually run it is to authenticate to Vanguard. So your normal account name and password. And then just like we did in the browser, you need to supply Vanguard either with access keys, so Vanguard can fetch the information from AWS automatically, or in the same way you can use the JSON data and use that as a basis for the model generation. We then need to select our high value assets. So we can use, for example, the instance IDs here. So this is our web server and our Bastion host. This is the name of an S3 bucket that we also set as a high value asset. And this is a database identifier for an RDS instance in AWS. So just like in the browser, we then set the high value assets here with this function, and then it's time to simulate. So basically all you need is these 4 lines of code to authenticate, download or generate the model, set the high value assets, and then run a simulation. So that is all that is needed to actually integrate this into your existing tooling or pipeline. And like we did in the browser, we need to select our attacker profile, and that's it. So we run the simulation, we get the results back, and the results are basically 2 parts. So you get probabilities and time to compromise for all your high value assets, and you also get a report part, which I will show you in a second. So this is basically what you get back. So for each type of asset, you get your ID, and then you get the probability and the time to compromise for each high value asset. So you can, as I mentioned earlier, track these values over time and see if they deviate when you make changes to your environment. But these IDs, for example, for an EC2 instance, they might change over time, because a lot of AWS customers, they deploy new instances, or they have auto-scaling. So these IDs may not be permanent. So what we can do then, instead of hard coding these IDs, we can use Boto3, which is the AWS Python SDK. And we can then fetch these IDs automatically or dynamically instead. So as an example, we can we authenticate to Boto3 here, and we ask for all of our EC2 instances, and we filter them on, in this case, on a tag called owner, where the value is Erik, me. So all of my EC2 instances, we fetch those and we filter those, and we get all the instance IDs that we need for Vanguard to run the simulation. And the same with S3, for example. If we want to get all of the buckets which have the string customer in its name, we can filter all of our buckets on that and then set that as high value assets in our environment. So by using that, we don't have to worry about IDs changing or anything like that, but we can select our environment and select high value assets dynamically based on names or tags, for example. Yeah, and as I mentioned, there is also a report part here in the results that we get. So apart from these high-level results, we also get basically the full results from the simulation. So this is all of the data from our model and from our simulation, which we then can use, for example, in Neo4j to draw a graph of our environment. And we can actually also use it and upload that data into Vanguard and get a report instantly. So let's say that you are running simulations continuously in your pipeline, and you get an alarm that your risk exposure has gone up by 30%. So then you might want to check the report. So why is this happening? You can then take this data that you get from the SDK, and you can actually upload it directly into securiCAD. So let's open a new tab here, and I will just show you how that works. So you get your report, you stored it somewhere. You can actually upload it here. So instead of choosing IAM user or uploading a new set of data, we can just pick our report here, pick our JSON, and we can instantly look at the report just like we did when we started the simulation from the browser. Yeah, so, and the last thing I want to cover is, I mentioned earlier that I uploaded vulnerability scanner data into the browser to actually get some context on our vulnerabilities. You can do that with the SDK as well. And we have a general format that you can use. So whatever vulnerability scanner you have, you can convert your data into this format, and you can upload it directly into Vanguard, and you can prioritize vulnerabilities from any type of vulnerability scanner. But we do support AWS Inspector, so the built-in vulnerability scanner. We support that natively, so there's a flag for fetching vulnerability scan data from that. Yeah, I think that was it for me. Thank you very much.
Thank you, Erik. But we have a couple questions, so you're not quite done yet. Thank you, everyone, for very enthusiastically asking questions. Unfortunately, there are more questions than we have time to answer for each session, but there are some general themes, so I'll pick out a few of those. And one of the questions that's come up multiple times is, can you talk a little bit about the support for other cloud services?
Yeah, so right now we only support AWS, but on our roadmap we are going for Azure and GCP. Hopefully later this year we will start supporting Azure, and we are moving into those other cloud service providers as well.
And then another question we have here from Saber is that a question around scale and how big environments can we handle?
Since we
or to qualify that question, for example, 100,000 vulnerabilities.
Yeah, so the simulation scales fairly well, and we have customers running simulations on thousands of EC2 instances with thousands of vulnerabilities, and we run our infrastructure on AWS ourselves, so we can scale up to bigger machines if needed be. But the limit that we have, there's no hard limit really, but a few 100,000 objects is what we have seen so far, and we haven't encountered any models larger than that so far. But of course, there is also the possibility to, if the environment is super huge, you can put chunks of it and simulate them separately, basically. Maybe a few accounts at a time or something like that.
Okay, great, thank you. And lastly, there are a couple of questions about the support for containers.
Yeah, so actually yesterday we opened a closed beta for container support. So if you have ECS and use CCR and Docker containers, we can actually support that now.